All right, this problem deserves a video rather than typing it out because I don't think I could do it justice typing it out. Also, I made the video and then something happened and I lost it in Raster. So anyway, um, so here we go. You're given that xy is on the unit circle, and you're given this. It's like a transformation. You give me x and y, so you give me a point in the plane, and I'm going to do something to it, and it gives a new point in the plane. Right, notice there's a comma in between here. So all of this calculation gives you the x coordinate of your output, and all of this stuff gives you the y coordinate of your output. Um, so the question is, show that this output is still on the unit circle. And then they want some geometric interpretation, but at least to say how do you show it's on the unit circle? Well, how do you show anything's on the unit circle? If I gave you the point 3,4 and say, is that on the unit circle? How would you check? Well, if you know the equation of the unit circle, x squared plus y squared equals 1, you could plug your points in. Plug the 3 in for x, the 4 in for y, and check. Is 3 squared plus 4 squared equal to 1? Well, not last time I checked, so no, this is not on the unit circle. But to check if this thing's on the unit circle, I'm going to plug this in for x and this in for y, and see if I get a 1 out. So here we go. As I said, I've already made this video, and now I'm doing it again. So I'm just going to walk you through the steps here. This doesn't seem to want to let me scroll. That's weird. All right, now I'm scrolling. Now I'm scrolling. Okay, so the x coordinate, the output, this whole thing is the x coordinate. So I'm taking that thing and squaring it. Then the whole y coordinate is this stuff, so I'm taking that and squaring it. And the question, is that equal to 1? I don't know that it's equal. I'm trying to show that it's equal to. So anyway, square it out. You got to FOIL it, right? So I've got this thing squared, and then minus 2 times this times that. That's all this stuff. Plus that thing squared, so that's this. And then add on to that this thing squared. So there's the x squared sine squared a. And then there's a 2 times the product of both of them. So that's all this stuff. And then there's a plus y squared. Right? As I said, I have this all written down already because I've already talked it through, but I got to talk it through again because the video was lost. So now, this thing squared was all this stuff, this thing squared was all that stuff. I'm adding them together. I noticed that there's a minus 2xy cos sine a from this one, and there's a plus 2xy cos sine a from that one, and those are going to cancel out. I then notice I've got an x squared cos squared a and an x squared sine squared a. I'm going to factor out the x squared. So that's a cos squared a plus sine squared a. Likewise, I've got a y squared sine squared and a y squared cos squared a. Factor out the y squared. So that's what I get here. But then cos squared a plus sine squared a is equal to 1. Sine squared a plus cosine squared a is equal to 1. So I just end up with an x squared times 1. That's this one. And a y squared times 1, that's that one, and they're added together. And the question now is x squared plus y squared equal to 1? Well, they told me up at the top here that xy is on the unit circle, so yes, x squared plus y squared is equal to 1 because it's on the unit circle. It satisfies that equation. So, okay, this point is on the unit circle. Now, what's the geometric interpretation? You know, I don't think it's at all obvious what the geometric interpretation is. And all I know is, what do I know? Okay. All right, this picture is big. Here's how I'm going to start. I've got the angle here, theta. So, sorry, blah, blah, blah. XY is on the unit circle, so here's the point XY. But if I draw a radius from the origin out to that point, then we're talking, the unit circle. The x coordinate is the cosine of theta. The y coordinate is the sine of theta. So that's what I'm saying here. X is some cosine of whatever this angle is. Y is sine of whatever that angle is. Okay. My result is somewhere else on the unit circle. I'm going to put it right there. The coordinates here I'm about to calculate, but that I started with xy, I did this thing and just showed that my output is somewhere else on the unit circle. Okay, but now I want to see what that output really is. So this is the definition that they gave me up above. This is how I calculate the output, that x coordinate, y coordinate. But I'm going to replace that x coordinate now by cos theta. X is cos theta. And y is being replaced by sine theta. Okay, so this right here is cos theta cos A minus sine theta sine A. That's just the x cos A minus y sine A with those two things plugged in. Likewise, this bit here, with the x being cos theta and the y being sine theta plugged in, turns into this thing. But then it's like, hey, I just learned about some identities, and I know that cos theta cos A minus sine theta sine A is actually just the cosine of theta plus A. And that cos A sine A plus sine A sine theta, can I say this right? Cosine theta sine A plus sine theta cosine A is just the sine of theta plus A. So the point that I end up with is cosine of this angle, comma, sine of the same angle, which means that that point right up here on the unit circle has coordinates cos theta plus A, sine theta plus A. So what's happened is we've taken this point xy and rotated it through an angle A to get to this point. And we just added A onto the angle that we had before. Okay. So this is rotation through an angle of A. Okay. The next thing they wanted us to do, why won't this let me scroll the way I want to, is I want to show that it's rotation. So, and I need to erase all this stuff because, hang on. So the next part of the problem was to show that this is equal to just xy. Okay. So what they want you to do is they want you to take xy and plug it into that thing right here, and then take the result of that and plug it into it again, but with a different angle this time. Use negative A. Okay. So what I'm going to do is I'm going to use this thing as the x coordinate, this thing as the y coordinate, and plug it in. So this stuff is equal to x times cosine of, I'm going to use a negative A this time. So the x, though, is this whole thing. I've got x cos A minus y sine A. That's the x coordinate of this output. And I'm going to multiply that by the cosine of, well, I'm doing r of negative A, so that's cosine of negative A here. And then minus y, y, but the y coordinate is all of this stuff. So I've got x sine A plus y cos A times the sine of this angle, negative A. That's just the x coordinate of the output. Then there's also the y coordinate of the output. What I want to do is I want to just look at this part and see that it's going to give me that x, because I don't know, is that equal to xy? And then we can do the same thing to see that the other stuff gives you y. But so what I've done here is I'm looking at this thing, but for the x and the y, I'm using all of this for x and all of that for y, because I'm taking the output of RA, I'm taking this output and plugging it into R negative A. So these A's are negative A's, but the inputs, the x and the y, are the outputs of what I started with. So all of this stuff and all that stuff for x and y. So anyway, here we go. Distribute this in. I've got x cos A cos negative A minus y sine A sine negative A. Scroll up a little bit if it lets me here. And then minus, so I'm going to distribute the minus and that thing in there. So I've got minus x sine A sine negative A. And I've got minus y cos A sine negative A. All right, so this times that times that. Now, the negative A's. Cosine's an even function. The cosine of negative A is the same as the cosine of A. So this thing right here, I'm still forgetting all the other stuff that I didn't do, right? So right here I've got x times, that's cosine squared A, because the negative cosine negative A is the same as cosine A, right? I've got a minus, no, wait a minute, sine, on the other hand, is an odd function, so the minus sign comes out in front. Let's turn that into a plus sign. This is plus y times the sine squared a, because the sine of negative a is negative sine a. Right? And then here, again, the sine of negative a is negative sine a. That's going to switch to a positive on the outside, so plus x sine squared a. And then here, the sine is uh, 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 why do I make mistakes? This was a sine a, this was cos a. Sorry, I distributed wrong. You probably caught it, and you're saying, when is Will going to actually see that? That was cos a. So back up. Dang. So this one is even. So this is minus y sine a cos a. So the minus sign just disappears there. All right, now let's try this again. The minus signs get together to a plus. That's going to be x sine squared a. And this minus and minus make a plus. And this is y cos a sine a. And I noticed that the y cos a sine a here and the y cos a sine a there have different signs, so those go away. I've got an x cos squared a and an x sine squared a, which if I factor the x out is x cos squared a plus sine squared a. But that stuff is 1, so 1 times x is just x. So all this stuff in the first, before the comma, turns into an x. Likewise, you could do the same thing again, plugging in to this side. X is all of that stuff times the sine of negative a, and the y is all of this stuff times the cosine of negative a, and see that you get a y out of the other side. I'm running out of time for my video, but that's the idea of what you're doing there. This is rotation. So if you rotate by a and then you rotate by negative a, you really should get back to where you started from. Okay. Anyway, if anyone wants me to do the rest of it, just post a reply and say that, and I can finish it. But I hope you got the idea that you do the same thing on the y side as we just did on the x side here.